Okay, here is my new double stack battery setup. So we have 2 rows. Okay, works the same way. There's your balancing, and all we have to do is add 2 25mm posts to separate them. Okay, and what I'm doing, I'm taking my my old style, and I'm updating them to this newer setup. So basically, all of my boards already have 1 row, and this one right here, my son actually just put it on upside down. So I just went in and put these on this side, but I build them a certain way. I put the connections on top, and then the fuses are on the bottom. And you can do it either way, but you know, you got to stay consistent once you create your ribbons. But anyways, 14 on 1 board. So it works the same. And these board was designed for this anyways. The guy that done them designed the boards to work like this. So the nice thing about it is, you know, now this one here, I haven't put a fuse on it yet. I actually need to do that. So right there by that plus, there's 2 contacts, and out there's a fusible link. You can actually put solder in a fuse that can be purchased, or what I do is use a 1/8 watt resistor wire, and it will burn into about 5 to 6 amps of draw. And then of course, same with these right here. These will burn into probably around that, maybe even sooner. And that's a fuse for each individual cell. Okay. But this right here lets you double your capacity per board. That way you're not paying for you know, a board and only being able to put 7 cells, but now 14. So I think I'm gonna like this a little better. Right now I'm building this. I'm gonna build a small one, and I got enough of these surface mounts. These are surface mounts, and they seem to be working pretty good. The only thing about it is where I've used these, because these have a pin that pokes through the board, and then you solder it from this side. Then I'm having to actually liquefy the solder, spread it out, and then take a grinder or Dremel and take off this pin, because it just sticks through just a couple, 2 or 3 millimeters, and give these right here more of a flatter surface to set on and then solder to. But it seems like this may work pretty well. And of course, you know, the expense of these, they're a little bit of an expense, you know, because you got to pay for the board, you got to pay for these right here, and then of course you got to pay for these, you know, the connectors, and then of course the standoffs, you know, and I think these average about 40 cents a piece. And if you can find them cheaper, let me know. But you know, these are brass, so they transfer the electricity okay. And of course, when you put these together, I got these posts tight. I just got to barely screw together. But here. So now, when these are connected, it's set on there like that. These are here contacts is what connects these 2 boards together. So now this is all 1 battery. Okay. And Wesley, this is right here. I'm kind of, you know, doing this video for you, buddy, so you better understand how these boards work. And you may already know, I don't know, but just in case, or anybody else that's trying to do a project like this. But anyways, so that basically, this right here on these boards, the contact on the bottom and the top side connect on the negative, and this is the positive. So once you put this on here, this all becomes one battery, okay? And then of course, when you hook up your ribbon, this becomes one cell. This becomes one cell. This becomes one cell, and so on, okay? So when you use your balancer and the ribbon is hooked in here, and all you're doing is hooking to the very top or the bottom or in the middle, however you want to do it. Doesn't really matter. But when you connect this negative, of course this negative will actually get connected to your BMS. Okay, most BMSs work off the negative. This negative will hook into your BMS. Your positive will go straight to your bus bar or however you got set up. Okay, mine's got a bus bar. So, and I got this, it runs to a switch. And then the switch is on off to break the connection from this battery bank. Okay, and this is 24 volts. And then I'm gonna hook another one up, connect these two together, and then that will be a 48 volt. Okay, and then with these being 3.7 nominal and 4.2 fully charged, I'll have up to 55, 56 volts, and can go way down around 48. Actually, I can go down about 42. So 21 volts at 3 volts a cell, you can go way down to 42 volts if your charge controller and your inverter will operate at that level. But that would be about the lowest point at about 3 volts, which technically we could go lower than that. But to stay in a safe range, that would be the best, only go about 3 volts. And then this right here, system, is, the nice thing about it, it's modular. Something happens to a cell, break it down, get you another cell, take this one out. There's no desoldering, there's no ripping the whole thing apart like some of these setups. Then you take that cell out, you get one that's really close in capacity, just like this one here. It's 2385. So if you find that get just another cell and go through and test some, and you can get you one that say it's 23. The 85 isn't going to be enough to really make a whole lot of difference. Maybe even 22 may not even hurt a whole lot. Okay, because these are going to balance between themselves. And this right here, once they balance out, the voltage will be the same between this one, all the way down. And of course, what you'll see if this one say went bad, you'd have to manually test and check each individual cell. And of course, you can do it right off this tab, see? And you would get to one that shows, low voltage. Of course, the whole pack with this, all these would be running down and running low, and your BMS would show you that if you have the one I'm using, which it runs off Bluetooth. And that's another nice thing, the Bluetooth BMS will show you all these voltages. And it's programmable on the high side of voltage, and it's programmable on the low side. So you can program it to say, okay, I want to go up to 4 volts, and I don't want to go any lower than 3 volts per cell. And that will control that. But like if you have a bad one, one just goes bad, then those will start dipping and running down. So what you'd have to do is go and check to see which one of these cells is, running a little lower, because what it's doing, it's going to start running the other cells down. But you would be able to tell which one is bad. And then, of course, just break this down, take that one out, replace it, and then screw it all back together, hook your ribbon up, reconnect, back in business. Not a whole lot of desoldering, not a bunch of breaking apart. I myself think it's it's a little bit of an expense at first, and I've spent a lot of money in getting this all kind of going and working. But I think in the end it's going to pay off. This stuff right here is fairly cheap, and I think the more people that get into this and this stuff starts getting bought more, I think it will help to drive the costs down on some of this stuff. And You know, these little PCB boards, you only about average about $2 a board. I mean, the shipping is what kind of drives it up a little bit. So it's not real bad. And of course, you know, the nice thing about it, I think this stuff will last a long, long time. You know, those that don't get abused, you know, you don't overcharge as far as trying to charge too fast or trying to take the energy out. So, you know, if you got a big battery bank of these, then, you know, you can run quite a bit, pulling up, you know, wattage. And just remember, you know, you're figuring out how much your watts you're pulling, your amps and volts. So if you got a higher voltage bank, then you have to run less amps, you know, both ways, charging and discharging. So if you have high volts, 50 some volts, it takes less amps to get the wattage you want. And remember, the lower the voltage, it takes higher amps. So anything like this, or even lead acid, if you run a low voltage, you got to run really high amperage to get the watts. So to produce the watts, it's volts times amps. So and everything is much more efficient. You know, if you check, I've done so much research on all this stuff, on voltages, on battery banks, and everything else. So they talk so much about, you know, everything had to be high amperage, okay, and because, you know, it's the figuring it up, you know, volts times watt or volts times amps, you know, and if you want to figure backward, you know, you could check your wattage you're pulling and see what your voltage is, and it'll basically figure out to how many amps you're pulling. Okay, so it all just it works together pretty well, and the more I learn about it, the better I get. Now, hopefully, eventually, I'm gonna get to a point where I can do these systems for other people and be really confident that I can be accurate and safe. You know, because I don't want to cause a problem. You know, and I want to make sure I've done it right for everybody. You know, consistent. And if I build a system for somebody, you know, I don't want them to come back later on saying, well, you know, it didn't work or it didn't work right. So that's why I'm pretty particular about, you know, making sure I get all my ducks in a row and everything works like it says it should, or whoever. Like the guy that designed these, you know, I mean, he came up with a great idea, and he had a guy helping design these boards. And this is about the third version. He's changed the version a little bit, changed the style. I think he even got now another version which he's rounding these corners. And I got to get that file yet, which I think that's a great idea. But, you know, I've already got several boards with sharp corners. But, yeah, he's actually got another version where he's rounded the corners of the boards, which will be even better because, you know, handling these, or say, let's say you want to wrap them. You want to put like a shrink wrap. You know, I've seen him talk about where, you know, you could put a shrink wrap around these, which it's going to hold in heat, which I don't know if that would be a good idea or not, but just for handling them, you know, when you move them from point to point or whatever, or you're working on them, you know, he decided around these corners for a little bit more safety as far as people not getting, you know, gouged and stuff, or trying to put them into a holder, because he actually has a metal enclosure that he sells, and then you can, I think you can get it about anywhere, but two sets of these, like, you know, if you had one stack here and you had another stack facing the other direction, you know, and then he's got like, you know, 30 rows, because it's like a 5 or 6 kilowatt box, you know, depending on the size of your cells. So, and then of course he's got everything facing in for all the ribbons, and then the power connections come out and go up. But you know, these fit perfectly in that box. So, you know, that worked out pretty well. But anyways, we'll just cut this short. It's been almost a 15-minute video. And so just show you what I'm doing here, kind of how it works. You know, hopefully the other day explanation on the video I gave you, Wes, was helped you out quite a bit. But just like these right here, these ports and that ribbon, and then I'll make one about the ribbon and how the ribbon works and how it hooks to the BMS. Okay, so I'll keep trying to make these videos for you, and anybody else out there, I'm just going to leave it kind of open to the public. And if anybody else is working with this type of style from Jehu, it'll help you as well, I hope. So, anyways, and of course this is your balance ribbon. Each one of these or each two of these go to one cell. And then of course the balance ribbon hooks in here. And I got the notches up. And these are 90 degree. Okay, so they go like this. So they got pins that are in 90 degrees, so they go through the board and they stick out the front. Okay, and you can see how they're mounted. They go through the holes. A little bit blurry. There you go. And so you could actually probably get the ones, and I think when he first started, he got the ones that was not 90, but they actually just stuck up. And then he just created a little system that connected them together from board to board. But he came up with the idea of this, which I think is great because I've made several ribbons, and the way I make my ribbons, I put the connector on the ribbon, stick it in here, and then move it up to here, and then find the next connector and set it on top and mark it, and then crimp it, and then of course when you pull it out and stick it in here, you got just a little bit of a bow in the ribbon. But what that is, that gives you just that little bit of extra ribbon to make sure it will reach. Because once you crimp it, it's crimped, so you can't really be taking it back apart, otherwise you kind of mess up the ribbon. Okay, so, and I'll do a video on how I do my ribbons and hook up the BMS later on, and that'll be for Wes and anybody else that needs to use it. Okay, so anyway, that's it for today. See you later.